Welcome to Unit 5. This is 5.1, Ratios and Similar Polygons. First off, a ratio is a comparison of two quantities by division. Right? We're comparing two numbers typically, such as A and B, as long as B is not 0 because it's on the denominator. We can write this three ways. First one is the normal way as a ratio is a fraction. We could do A with a colon B. And then you could just write it in words A to B, and that's how all three of these are going to be read, A to B. And that is how you read a ratio. A and B must be in the same units and in the simplest form in order to finish the ratio. So here, a bonsai bald cypress tree are smaller versions of full-size trees called senators. The senator stands 118 feet tall. What is the ratio of height of the bonsai, which is 15 inches to the senator? So it said bonsai to senator, meaning bonsai on top, senator underneath. We have 15 inches over 118 feet. The issue is that they're not in the same units. So we're going to change the feet to inches. So 118 times 12 is 1,416. 15 over 416, if we can simplify it, we will. And that becomes 5 over 472. Notice the units are the same, so we're allowed to drop them with a ratio like this. Our next example, the scale of a map at the right is 1 inches to 26 miles. So to find the actual distance, if the distance is 1.25 inches, we have our map to actual as 1 inch to 26 miles. And the distance 1.25 inches is on the map, so we can put 1.25 inches over x, which is what we want, the actual. And here we can cross multiply. We get 1 inch times x equals 1.25 inches times 26 miles. And of course, if we divide by 1 inch on both sides, the inches cancel, leaving us just miles. And we can do 1.25 times 26, which gives us 32.5 miles. Okay, so we solve a little proportion there. An extended ratio compares three or more numbers, A to B to C, therefore A to B, B to C, and A to C. The idea is that all of them can be compared. The lengths of the sides of a triangle are in the ratio of 3 to 5 to 6. The perimeter is 98. Perimeter, you add up all three, and it equals the perimeter. The issue is that it's a ratio. It's not so much the actual side lengths. They're not 3 inches, 5 inches, and 6 inches. It's 3 times some number, 5 times some number, 6 times some number, and that number is x. So 3x, 5x, and 6x, if we add them up, it equals the perimeter, 98. Combine like terms and divide, we get x is 7. So the lengths of the longest side is the 6x in there. 7 times 6 is 42. 42 inches. A proportion is where you set two ratios equal to each other. So here we got A over B equals C over D. To solve a proportion, we cross multiply. So to name them, we have the extremes. The extremes is always the top left, bottom right. And the means are the bottom left, top right. So when you cross multiply, you multiply your extremes, you multiply your means, and you set them equal. So here, our extremes is 9 and 6, our means is 3 and m. When we multiply, we get 3m equals 54, so m equals 18. In this question, our extremes are b plus 10 and 8. Our means are 6 and b minus 9. We're going to multiply by distributing, so 8 times b plus 10, which gives us 8b plus 80. And that equals 6b minus 54. So here, when we solve, we get b is negative 67. Other ways to write it. So a over b equals c over d can be, we can switch them flipping both. This is called reciprocals. So if you flip both, they're still equal. It's called a reciprocal. You could also exchange the means, which is called interchange means. You could also add the denominator to the numerator of both. Just the denominator to the numerator, you're not adding it to both the top and bottom, just the top. And that's called addition of denominators. And these just help us solve questions later on. Here's an example. We have a triangle. AB is x, AC is 25. We can set up a proportion knowing that the ratio is 3 to 5. 3 over 5 equals x over 25. And then we cross multiply. We get 5x equals 75 and x equals 15. Our final example here, we're going to use the addition of denominators to kind of solve for this, but the idea is that 3 and 6 match. X and then the whole thing of 24 is going to match. So now we can just cross multiply. X times 6 is 6x equals 12. So therefore the length is 12. BD is therefore 9. If we're looking for all parts. Right, moving on to similar polygons. Two polygons are similar if corresponding angles are congruent and corresponding sides are proportional. The angles are A and E, B and F, C and G, D and H. The sides are A, B and EF, B, C and FG, C, D and GH, and DA and HE. These are our proportionality statements. The idea is that their ratios are all equal. Our similarity statement would just be that ABCD is similar to EFGH. Okay, so here list all pairs of congruent angles. Knowing that RST is similar to XYZ, we know that R is congruent to X, that angle Y is congruent to angle S, and that angle T is congruent to angle Z. The proportionality statement, we know that RS over XY is 20 over 12. So to find the scale factor, we just simplify it to 5/3. And they're all ST over YZ is going to simplify to 5/3, and TR to ZX is going to simplify to 5/3. Because all three are the same ratio, we know that the triangles are in fact similar. So we can write a proportionality statement, RS over XY equals ST over YZ equals TR over ZX. If two polygons are similar, then the ratio of the lengths of their corresponding sides is called the scale factor. So here to find the scale factor, we just have to do one set. We can do FJ over ZY to find the scale factor. And we find that it's 20 over 16 simplifies down to 5/4. All the angles are congruent, and all of the sides ratios became 5/4, so we know they are in fact similar, and that the scale factor is 5/4. Next, Mr. Hacker is 6 feet tall and standing 10 feet from a tree, so we got to draw this. So we got a tree here, and Mr. Hacker is somewhere here. We know that Mr. Hacker is 6 feet. We know that he has an 11-foot shadow. We know that he's 10 feet away from the tree. And we want to know the tree, which is x. So we can actually set up a proportion here. We want to do the ratio of the tree with Hacker and the ratio of the shadow to the tree shadow. So the ratio of Hacker to the tree would be 6 over x, or x over 6. So we're going to do x over 6. Because we did the whole tree to Hacker, we're going to do the whole shadow, which is 21, over Hacker shadow, which is 11. Cross multiply here, we get 11x equals 126, so x equals 11.45. That is, however, not in inches and feet. 11 feet, but we have to convert 0.45 into inches, so we multiply that by 12, and we find that it's 5 inches. Perimeters of similar polygons, just like with their lengths, their perimeters are also similar. So we just have to find the ratio of the sides, and that's the ratio of the perimeters. So here, find the lengths of the missing altitude. We know that the ratio would be 6 to 8, which is also 3 to 4. And we can set up a proportion, 3 to 4 equals x over 20. And then we can solve. Here to solve, we just do 3 times 20, which is 60, equals 4 times x. So x is 15. So the length of SP is 16. Alright, that's all there is to similar polygons. Good luck on the practice.